So we're told that a model rocket is launched with an initial velocity of 120 feet per second from an initial height of 80 feet off the ground. The height of the rocket from the ground t seconds after launch is modeled by the equation h of t equals negative 16t squared plus 120t plus 80. Now, if you are familiar with physics, this equation is the same as the physics equation. This is 1/2 g. This is the initial velocity, and this is the initial height. And the gravity in the English system is 32.2 feet per second, and so we're just approximating that by cutting 32.2 in half. We would get 16.1, and we're just making that 16 to make our numbers round and make this look a little easier. So anyway, given this scenario, we've been asked 3 questions. The first question is, how long does it take the rocket to reach its maximum height? So from the time you launch it, how long does it take to reach its maximum height? Second, we've been asked, what is the maximum height? And then third, we've been asked, how long after launch does the rocket hit the ground? And another way to phrase that third question is, how long is the rocket in the air? Okay, so we've been asked those 3 questions, and before we do anything with this, I want to remind everybody of something, which is this is a quadratic, and the leading term is negative. And so what we're going to see is we're going to see a picture that looks something like this. Okay, we have T and we have H. Okay, and our rocket is launched from a height of 80 feet, so it's going to launch from here, and it's going to go up and down. Okay. And so we've been asked a couple of things. The first thing we've been asked is how far after you launch it, which is going to be this time right here. Okay. We've been asked for a height, which is going to be this value right here. And then we've been asked for how long it stays in the air, which is this value right here. So we're looking for 2 x values and 1 y value. And this x value and this y value occur at the vertex. So we need to find that. So anyway, so given this scenario, we need to find these answers. So how long does it take the rocket to reach its maximum height? Okay, so we are looking for an x-coordinate of the vertex. Well, the x-coordinate of a vertex for a polynomial in expanded form is always going to be negative b over 2a. Okay, and so when I look at this, you know, you've got, remember the old form for the quadratic formula, ax squared plus bx plus c? Well, this is a and this is b. So negative b would be negative 120. And 2 times a would be 2 times negative 16. So when I take negative 120 divided by negative 32, I get 3.75. So now, here's what I know. It takes 3.75 seconds from launch to reach its highest point. Okay? It will take this rocket, this divided by 2 this, that's how long it's going to take this rocket to reach its highest point, 3.75 seconds. Okay? So that's question A. That's done. Question B says, what is the maximum height of the rocket? Well, the y-coordinate of the vertex equals f of negative b over 2a, which is f of 3.75. So basically what I need to do is take my equation and plug in this number for t. So I get negative 16 times 3.75 squared plus 120 times 3.75 plus 80. Okay? And when I add all of those together, I come up with 305. And so what that means is the rocket reaches a maximum height of 305 feet. And it takes 3.75 seconds from the time of launch to reach that height. Now, here's the trick. Question C is where a lot of people get in trouble. Because a lot of people say to me, well, If it takes that long to get up to its maximum, then you should double that, and that's how long it takes to reach the ground. And that is not true in this case, because the rocket is not launched from the ground. It's launched from 80 feet above the ground. So this graph is not symmetrical, because we've got to go from 80 feet up to 305 and then down to 0. So it's going to take longer to get down than it did to get up, because I started at 80 feet off the ground. So you can't just take this time and multiply it by 2. So what do you need to do? Well, remember, folks, this is a quadratic, and it's going to have 2 x-intercepts. Okay? We find those x-intercepts by setting equal to 0 and factoring, or using the quadratic formula, or completing the square. Well, I'm going to have a negative one, and I'm going to have a positive one. And my picture tells me I want to keep the positive one. So, I'm going to say x equals the opposite of b plus or minus b squared minus 4 times a times c all over 2a. Okay? And then, of course, if I simplify that, I end up with negative 120 plus or minus the square root of 19,520 over negative 32. And if I plug those two into my calculator, I get 8.116 seconds. And I get negative 0.616 seconds. Now, from my picture, I know I don't want the negative answer, so this is going to be the answer that I choose. So how long does it take the rocket to hit the ground after we launch it? It's 8.116 seconds. So it's less than 4 seconds to get to its maximum and more than 8 seconds to reach the ground again. And this is an equation that's used very commonly throughout physics and engineering to model the path of different projectiles given some initial conditions. It's very, very useful and very, very effective equation for that. So if you have any questions about this, please let me know.